Good morning, everyone. Thank you for joining us today. In our last deep dive, we kind of laid out the global rulebook for AI, figuring out the what and the why of governance. Today, we're going to roll up our sleeves and move from the blueprint to the actual build. This isn't about theory anymore. It's all about practice. We're zeroing in on the how. How does a modern company take these abstract ideas of AI safety and forge them into a real, living, operational system for AI trust, risk, and security management, or what we in the industry just call TRiSM?
And yeah, that quote right there, that nails our mission for today. Think of this as a practical, engineering-focused guide. We're literally laying out the architecture for building responsible AI programs. And this is absolutely critical, especially for anyone operating where new rules are popping up, like Canada's proposed Artificial Intelligence and Data Act, or ADA. We're going to walk through the structures, the processes, and the checks and balances you need to manage an AI model through its entire life, from just a spark of an idea all the way to its eventual retirement.
Okay, so let's get into it. We're going to build this framework from the top down, which I think is a really logical way to think about it. First, we'll talk about the strategic brain of the operation, the governance committee that sets the rules of the road. Then, we'll get into the operational backbone that makes it all happen day to day, model lifecycle management. And finally, we'll cover the essential verification checkpoints, the audits and assessments that make sure everything is solid. Strategy, operations, verification. It's a great mental model for building this stuff at an enterprise level.
So, let's start at the very top. In the early days of AI in the enterprise, things were a bit like the Wild West. You had these small, brilliant teams working on their own, not a lot of oversight. That ad hoc approach just doesn't fly anymore. Today, the mature solution is a formal AI governance committee. And the best way to think about it is as the human steering wheel for the whole AI program. It's what keeps the company driving toward real value without accidentally veering off a cliff.
Which of course brings us to the most basic question. What is this committee actually supposed to do? What's its core mission?
So its number one job is to completely shift the company's mindset from reactive to proactive. Instead of scrambling to put out fires after a model goes haywire in production and causes a PR nightmare, the committee's job is to write the fire codes from the get-go. This is the group that owns, creates, and really champions the entire TRiSM framework. That's trust, risk, and security management. They make sure every single AI project, whether it's a simple little chatbot or a high-stakes loan approval model, lines up with the company's values, its risk tolerance, and all its legal duties. It's really all about making AI development intentional and disciplined from day one.
Okay, so if this committee is the steering wheel, a pretty important question is, who gets their hands on it? The makeup of this group is absolutely everything.
Now, this is where things get really interesting, because a classic mistake is to pack this committee with only tech people. But AIRisks isn't just a tech problem, it's a socio-technical one. You need a 360-degree view. A good committee is really a coalition. You have your executive sponsor, a CTO or chief AI officer, who gives it teeth. You have your data science leaders who bring the deep technical knowledge. But then you bring in legal and compliance, who are trying to navigate the regulatory minefield. You add privacy and cybersecurity folks who are focused on specific threats. And then, and this is so crucial, you add two more voices. An ethicist, who's asking, should we do this, instead of just can we do this? And the business line leaders. These are the people on the front lines who can say, hey, your model might be 98% accurate, but let me tell you how that 2% error is going to crush our actual customers. It's that constructive tension between all these different viewpoints that leads to really solid decisions.
So we've got the team together. Now what's their playbook? What do they actually do in their meetings? Let's break down their core responsibilities.
Right? Their job is to govern, not just to advise. So first, they establish the big picture principles and policies for the whole company. Second, they act like a triage nurse for new projects, creating a risk tiering system. A low-risk tool for summarizing internal documents just doesn't need the same level of scrutiny as a high-risk system for an autonomous vehicle, right? So they focus their energy where it matters most. Third, and this is huge, they have the final go, no-go call on those high-risk projects. They have veto power. Fourth, they set the technical standards for everyone, things like mandatory documentation, what fairness tools to use, or what security tests are required. And finally, they act as the court of last resort. When a dev team runs into a really thorny ethical problem they can't solve, the committee is where it goes for the final call.
Okay, so we've got our strategic brain with the governance committee. Now we need the operational backbone that turns that strategy into something repeatable and scalable. That backbone is a disciplined model lifecycle management framework.
And this brings us to a really key concept, model lifecycle management. Now, as a tech-savvy audience, you're all probably familiar with MLOps. So How do these two ideas relate? Are they the same thing?
Well, think of model lifecycle management as the next evolution of MLOps. MLOps did a fantastic job of bringing the discipline of DevOps, automation, CI/CD, to the world of machine learning. But its main focus was always on speed and stability. Model lifecycle management takes all of that great stuff and then adds explicit mandatory guardrails for trust, risk, and security. The key idea here is that risk management isn't some separate step at the end. It's built right into the pipeline with automated checks and required documentation. It's really a full framework for managing a model from its very first conception, its cradle, all the way to its formal retirement, its grave.
So what does that cradle-to-graves journey actually look like? What are the key phases we need to manage in practice?
A mature life cycle usually has about 5 phases. It all starts with Phase 1, initiation and risk screening. Here, every new idea gets logged and scored for risk, immediately flagging the high-risk ones for the governance committee. Phase 2 is data governance and development. This is where the core build happens, but in a structured, auditable way. Phase 3 is pre-deployment validation, a super important quality check we'll talk more about in a bit. Phase 4 is deployment and continuous monitoring, and this is so important. Deployment is the starting line, not the finish line. We have to constantly monitor for things like model drift, where the model's predictions get worse over time, and data drift, where the live data it's seeing starts to look different from its training data. A big economic shift, for instance, could trigger both. And finally, Phase 5 is model retirement, a formal process for taking models offline when they're no longer needed or working well.
Now, inside that development phase, 2 really powerful documentation tools have come along that are just essential for governance and transparency. They're called model cards and data sheets for datasets. Let's break down what they are.
Honestly, the best way to think about these is as the nutrition labels for your AI systems. A data sheet for a dataset, an idea pioneered by researchers like Timnit Gebru, goes along with the training data. It tells you where the data came from, how it was collected, what's in it, and any known biases. It's all about understanding your ingredients. Then, the model card goes with the final, trained model. It's like the model's spec sheet. It shows its performance, how it performs on different groups to check for fairness, and it clearly states what it's supposed to be used for and, just as importantly, what it's not supposed to be used for. Together, these 2 documents create the transparency that everyone, from developers to auditors, really need.
So, we've got our strategy from the committee and our operational process in the lifecycle. The third and final pillar is the verification checkpoint. This is the tough, independent quality gate where we really stress test our systems before we let them out into the wild where they can affect people's lives. At this checkpoint, there are 2 key processes: the AI Impact Assessment, or AIA, and the AI Audit. They sound pretty similar, but they focus on fundamentally different things. It's really important to get the distinction. The easiest way to think about this is that an AI Impact Assessment looks outward, while an AI Audit looks inward. The AIA is a strategic review. It's trying to spot potential harm to society. It asks the big questions like, what could be the unintended consequences of this system? Could it hurt a vulnerable community? And this is actually becoming a legal requirement in places like Canada for high-impact systems. On the other hand, an AI audit is a deep technical inspection looking inward. It asks, does this system actually meet our technical requirements for things like accuracy, security, and fairness? One is about societal risk, the other is about technical integrity. You absolutely need both.
Okay, so let's zoom in on that technical audit. What does a really thorough, comprehensive audit actually look at when you pop the hood?
A good audit is a multi-pronged investigation. The auditors will dig into the training data, looking for bias or sketchy collection methods. They'll independently run fairness metrics to see if the model impacts certain groups differently. On the security side, they'll do intensive testing, often through what's called red teaming, where a separate team of ethical hackers literally tries to break the model, looking for vulnerabilities like data poisoning or prompt injection attacks. They'll check the documentation, like the model card, to make sure it's accurate. And of course, they'll test performance and robustness, just hammering the model with weird edge cases and noisy data to see where it starts to fail.
Now, this all might sound super new and complicated, but what's really fascinating is that one industry has actually been doing this kind of thing for years. So how on earth did banking become this unexpected leader in AI governance?
Yeah, the financial services industry actually gives us a fantastic blueprint. For decades, way before the current AI boom, banks have had to follow strict rules for what's called model risk management, or MRM. As they started using machine learning for things like credit scores and fraud detection, they just extended these battle-tested MRM frameworks. A core idea in MRM is the 3 lines of defense: The first line is the developers themselves. The second is an independent MRM team that has to validate and challenge every single model before it can go live. And the third line is internal audit, which provides another layer of review. This structured, independent validation process is a great template that a lot of other industries are now rushing to copy.
All right. We have gone all the way from the high-level strategy committee down to the real nuts and bolts of technical audits. So, if there's one single idea to walk away with today, what is the real key to operationalizing AI risk management?
The most important thing to remember is this. Responsible AI is not just a checkbox you tick off before you launch something. It's not an afterthought. It is a continuous, deeply embedded discipline for the whole organization. It absolutely requires the synergy of all three things we talked about: the strategic oversight from the governance committee, the operational control from the model lifecycle, and the objective proof from audits and assessments. It's the hard, systematic work of building an organizational immune system that can safely handle the power of AI.
And that's really the question I want to leave you with. AI isn't some future thing. It's here now. It's live, it's in production, and it's making important decisions today. So the real question is, have our organizations built the structures, the processes, and the discipline needed to manage it responsibly? That wraps up our deep dive on operationalizing AI risk. Be sure to join us next time as we dig into a huge related challenge in the privacy paradox, fueling AI without burning trust. Thank you so much for joining us today. We invite you to subscribe to our channel, Tech, AI, and Beyond, for more deep dives into the technologies that are shaping our world.